Systems of equations and functions. In number one, we have a system of equations that is two equations with two variables, x and y, and we're asked to find the x value of the solution. So if we're finding the x value, we want to eliminate y. So this is the column we're concentrating on. We want to add the equations together, and we would like it if these two terms canceled one another out. So we're aiming for two coefficients here with opposite signs and both equal in absolute value. So we're looking for the smallest number that 10 divides into and 25 divides into, and that would be 50. So we can get a coefficient of minus 50 here if we multiply both sides by 5. Remember, you can multiply two sides of an equation by the same number. That's one of the basic operations. And here, we can get a positive 50 over here if we multiply both sides of this equation by 2. Let's rewrite our system. Here on the left, we're multiplying by 5, so we have 35x. 5 times minus 10, minus 50y, equal 5. And in the second line, we have 2 times 2x, that's 4x, plus 50y is equal to 4. And now we're ready to add the equations together because we see this column, the y column, will cancel. In the x column, we have 35x plus 4x, so that's 39x. Okay, this cancels. Is equal to 5 plus 4, 9. And finally, just solve for x. Divide both sides by 39. And we have x is equal to 9 over 39. We won't find the y value because we were just asked to find the x value. All right, in this second example, we want to find the y value. So we're going to eliminate x here. So now we're concentrating on the x column. And we want to get two coefficients here with opposite signs that are the same in absolute value. So we're looking for a number that 2 divides into and 3 divides into. And the smallest such number is 6. So let's say we multiply the top equation by 3, both sides. And the bottom will multiply by minus 2. So here we'll get a coefficient of 6 and here minus 6. Okay, let's rewrite the system. Multiplying by 3, we have 6x minus 15y is equal to 3. And the second equation, we have minus 6x minus 4y is equal to positive 2. Now we're ready to add the two equations together because the x's will cancel. And here we'll have minus 19y is equal to 5. And now solve for y, just divide both sides by minus 19. And y is equal to minus 5 over 19. In number 3, we're asked to find both x and y solutions. So we'll start by eliminating either x or y. All right, I don't see that one is more advantageous than the other, so let's start by eliminating x, this first column. So I'm aiming for a 10 and a minus 10. 10 is the smallest number that both 5 and 2 divides into. All right, so let's multiply the top equation by 2. And the bottom equation by minus 5. All right, multiplying this, we have 10x minus 6y is equal to minus 16. And the bottom we have minus 10x plus 35y is equal to 45. Okay, now add the columns together, add the two equations. These cancel. And here we have 29y is equal to 29. And now just divide by 29 both sides. And we have that y is equal to 1. And now we want to find x. And we'll do that by substituting y equal 1 in either equation. I'll just copy down the first one. 5x minus 3y is equal to negative 8. And I'm going to put the 1 right here. Okay, y equal 1. So we have 5x minus 3 is equal to negative 8. And we'll just solve, add 3. And we get that 5x is equal to minus 5. Dividing both sides by 5, we get that x is equal to minus 1. So there's the y solution, and there's the x solution. All right, number 5, we have a function f of x equal to this expression, and we're asked to find f of minus 3, which basically means substitute in minus 3 for x. All right, so let's do that. So f of minus 3 is equal to 5 minus 3, and instead of x, I'm just putting parentheses. And then the denominator also parentheses minus 2. And here I have, instead of x squared, I have parentheses squared. And just put the minus 3 right in those parentheses. So here on top we have 5 plus 9. And here we have minus 3 minus 2 times 9. All right, let's keep going. So in the numerator, 5 plus 9, that's 14. And then in the denominator, we have minus 3 minus 18. So that's 14 divided by negative 21. We might as well reduce this, divide top and bottom by 7. So we have 2 divided by negative 3. And here in number 5, we want to find the domain. Remember, loosely, the way we think of the domain, we think of it as all possible x values that can be substituted into our function and that yield a y value. When we have, in A, we have a rational function, we have a denominator, and we know that the denominator can't be 0. So let's figure out which x values yield a 0 denominator. Okay, so to find out where the denominator is equal to 0, hopefully this factors. We'll factor it and see where this is equal to 0. All right, so this factors as, actually I see now that I left, when I typed this, I left out a 5. So let me put that in here. Otherwise this actually does not factor. So let's stick in that 5 there, and I'll correct it on the original paper. So here we have x squared minus 5x plus 6. All right, now that factors easily, x minus 3, x minus 2. Okay, so this function is equal to 0. I mean, the denominator is equal to 0 when x equals 3 or x equals 2. So we want to avoid 3 and 2. So we express our domain like this. the symbol capital X often is used for domain. And we say x is equal to, and then just indicate that x cannot equal 3 and x cannot equal 2. And the assumption is that the domain is everything else except 3 and 2. All right, now in B we don't have a rational function. We have a function that contains a square root. And we know that the square root of a negative number is not a real number. So we want to only take the square root of numbers that are greater than or equal to 0. So we're only going to use x values that give us an expression here such that 3 plus 5x is greater than or equal to 0. So let's write that down. We want 3 plus 5x to be greater than or equal to 0. And now just solve for x. So we're going to subtract 3. All right, so we want 5x greater than or equal to minus 3. And just divide by 5. And we see that we only want x values greater than or equal to minus 3 over 5. Okay, and that's our domain. And in part C, we have a square root and we also have a denominator. So we require that what's underneath the square root be greater than 0, not greater than or equal to, but greater than 0, because we don't want to take the square root of a negative, and we don't want the denominator to be equal to 0, so we remove the 0 as well. So if we have a square root in the denominator, just require that it be greater than 0. All right, so we're going to write down 5 minus x greater than 0. Okay, if you subtract 5, we have minus x greater than minus 5. And if we divide that by that negative 1, all right, dividing by a negative, we have to switch the direction here. So we get x less than 5. And that's our domain.